Hey everyone, welcome back. This is a big day. We are going to be changing how we program. We're going to become smarter and better. So, it's the old saying says you can't work if you can't work harder, work smarter. And that's what we're going to do. We've been doing a lot of just coding straight up, typing, what we want to do, doing if statements, things like that. But we need to start putting our code in functions, in groups, in specific areas. We need to start organizing our code. So that's what today is all about. So here's what I want to do. I want to start with from turtle import. Well, for just a second, we don't need to worry about this too much. But let's go ahead and let's look at the variables and let's run that right there. I'm just going to call this intro to functions. Okay. And I've just run this and look at all this stuff that we can do. See these words function? So a function is something that you call not on an object, but just directly, like the hide turtle and all that. So the turtle is a really cool module because it has both functions and methods. Very effective. Look at all these different things. Well, you know what? This is kind of like overwhelming. Notice these strange numbers and letters. This is called hexadecimal. This is actually the location of where that function is in the memory. It's a reference to it. So we've also seen how we have these classes. Well, we're going to clean up our code right now by not importing all of that. I want to deal with functions today. So let's just import some functions that we're going to need. We can always come back and add more later. I want to be able to go forward. Backward might be nice. I want to be able to turn left. I want to be able to turn right. And make a circle. All right, so let's run this code. And let's take a look at our variables now. All right, this is a pretty reasonable set of things that I can do now. I have these choices that I can do because that's what I've loaded up. And so if I want to call them here, I can. I can go forward 100, and we'll see that it's going to bring up my Python turtle graphics window, and my turtle, which is the shape of an arrow, has just moved forward 100 pixels. Super. But, I like these functions, but I want to add more. I want to add more things that our turtles can do. So let's get right to that. The first thing I want to do is I want to make my turtle able to make a rectangle. So I'm going to add that. I'm going to say def for define rectangle. Now, all functions have to have these parentheses at the end. That's part of what makes them recognizable to Python as a function. And then we put this colon. So look at the behavior there. Def rectangle. Okay? Now, let's take a look at what we can do to make it be a rectangle. So how would I move? Well, first, maybe I would go forward 100. Actually, let's do this in a loop. For I in range 2. I'm just going to do this twice. I'm going to go forward 100. And we're just using the basic generic turtle because I'm not calling it on an object. We're using the functions. I'm going to turn left 90. Then I'll go forward 50. And I'll turn left 90. All right, let's run the module. And by running it, look what I have in my variables now. Backward, circle, forward, left, and what's that? Rectangle, right? It's loaded up in somewhere in the memory. This memory address is 409FC48. And we'll learn how to read those numbers later, but they're really not of any great importance. I just want you to know that it's been loaded. So yeah, I can still run forward. And forward takes a number of pixels to move, so there's that. Okay, I'm going to go ahead and add some more to this, though. I am going to make my picture have a rectangle. So our rectangle did not have any parameters, so I don't put any parameters there. And I've drawn a rectangle. And if you position these two windows kind of where you can split screen it, you'll be able to see it happen in real time. I'll tell you what, though, let's turn left like 45 degrees and go forward. Oh, I don't know. Actually, let's go backward. Because I loaded that one. I'll go backward 200. And I've gone back now. And I'm going to make a rectangle facing in this direction. Just to show you that I can. And there you go. I got my rectangle. Pretty neat, huh? So we've actually taken what was a pretty useful module called Turtle, and we have added to it by importing exactly what we wanted and then adding something that didn't already exist. Let's make some changes. Okay, so this rectangle function, pretty cool, but it makes every rectangle have a side length of 150. Um, I'd like to make it be customizable in the same way that the circle method is customizable with a radius. The forward, you get to tell it how far forward to go. So let's call this length, comma width. So now when the user gives me a number, they have to give me 2 because I have 2 parameters here. When you call the function, these are actually called arguments. So it's a little confusing. I wish we just always called them parameters. But the person calling the function puts in an argument, and that argument will go into the parameters of the function where you have written it. So where you're writing a function, they're called parameters. So length and width, we got 2 parameters, so you'll have to supply both of them. And then we can change this to say forward length. Okay, and then forward width. So now if we try this out, and I'm going to go ahead and try and make it to where I can see both. Hold on. So I want to be able to see both my code and my window all at the same time. There we go. So let's call rectangle, and I have to supply it with the length. I'll say 50 and 300. All right, so that's a little bit more exciting. I like being able to see it happen while I'm coding. It's pretty cool, right? And we can give it all sorts of lengths, right? We can say rectangle 200, comma 200. Maybe I want to make it a square, right? So that's pretty handy. There are some other things you can do. You can actually give it default values for the parameters, which is kind of interesting. That's a very Python exclusive kind of thing to do. But I'll let you look that up if you want. Is how to make your parameters have a default value. But for now, we'll just leave it like that. Okay, so next thing I want to do. That's pretty neat. We've added the ability. We can go forward, backward, turn left, make a circle, turn right. Now we can make a rectangle, and we get to decide what length to make it. So the next thing I want to do, though, is I want to define a square. So to make a square, I need a length, but that's all I need is a single length. Now, once you've written a function, you don't need to redo all that work. We can use it because I can call another function from inside this one. So a square is just a rectangle with the length and width the same amount. So I'm going to call rectangle. So already you're seeing how functions can be really efficient. So let's make a circle right quick. We haven't done one just for fun. There's my circle. And then I'm going to make, let's see here. How about a square? Actually, you know what? I'm going to go backward half of that length. Let's go backward 50. Nope, I want to go backward 50 more. There we go. Now I'm going to make a square of side length 200. I think this will be cool. Yeah, kind of neat, huh? So yeah, that's what you can do. Let's turn right, actually. Let's turn right 90 degrees and then make a rectangle 20 by 200, just for fun. All right, so there we go. Rectangle and square, we've added it. Let's add some more. How about a polygon? Okay, so this one will be a little more challenging. Def polygon, and these will be a regular polygon, so they're going to have to tell us a number of sides and a length. So how do we make a specific polygon? Well, when you make a polygon, you go around. Let me clear all this out from a different lesson here. When you make a polygon that's a regular polygon, we need to go a full 360 degrees around. Like say I'm making a hexagon, so I'll go forward some amount, and then I have to turn. And then I have to go this way and turn, and then I have to go this way and turn, and then I have to go this way and turn, this way and turn, this way and turn. And so the amount that I turn from the direction I'm going I have to eventually end up back face the way I started, right? That's otherwise I didn't finish. So because when you're last done, you have to be facing exactly the direction you were facing, never before and not after. So how many degrees is it to turn all the way around so you're facing where you were again? Well, that's 360 degrees, right? And if I have to divide it evenly in the 6 sides, I'm going to divide that by 6. Or more generally, I'm going to divide that by the sides. Let's give it a try. So, we'll go here to, oops, that's the wrong coding language there. There we go. And I'm going to say for I in range sides. So we're going to do it sides times. We're going to go forward the length, and we're going to turn left 360 divided by the sides. Okay? And there we go. That should do it. Let's try it. So I'm going to say polygon, 6 sides, each of side length 50. Cool. I like that. Let's do another one. How about polygon, 7 of side length 50? Oops, I did 5. There we go. 8. Make it an octagon. And yeah, it is getting a little bit bigger each time because you got more sides and we're keeping the side length the same. So remember, we're not keeping the diameter of the shape the same. So don't be surprised that it is slowly getting bigger. Because if you really wanted to keep the diameter of the shape or keep it confined to the same circle, we'd have to decrease the side lengths to correspond with that. Notice how it's looking more and more circular, right? Anyway, well, you can have fun with that. So that's pretty neat, right? You could use a for loop right here to make different polygons of the same size, right? So we could be like, let me turn right 90. I'm going to go forward 200. I don't have a pinup or anything because I didn't import it, right? I did not import pinup. If you want to do that, you're going to have to add it to our list up here because I didn't do dot star, which is nice, better. So I'm going to say for I in range 360, I'm going to say polygon. Well, you know what? Let's change our range. Let's give it a starting value. I want to start at 3, and I want to go up to 360. That's good. And so I'm going to say polygon, side lengths I, 10. All right. All right, so we should be making tiny little polygons. Ooh, this is going to go on forever, by the way. Some pretty neat stuff. So our turtle is going to be busy, but you get the idea, right? While that's doing that, though, let's talk about some other things that we can do. First of all, notice that I'm calling all of these functions from inside my shell. That's so that we can practice and see it in real time. Please understand that is not at all necessary. I can make a function called main, and then I can run main and make all the stuff that I want to have done in it. And that's very typical to have a function called main and main be what happens when someone calls main. And so you can do the code here. I'll say, this is my program. And then I can say, forward 100. Then I could say square 50, rectangle 20, 30, polygon 6, 40. So now I've got this main, right? I'm going to go ahead and run it so it'll shut that down. Sorry I didn't let it finish for those of you that were rooting it on. All right, so now I can actually run the program by just saying main, and I get a lot of the different steps, including these different functions that I've called. So that's really common. So when you want to, so you have a bunch of functions to help you do code, and then you have a main that is kind of like the entry point for the program. One final thing, and this may not make a lot of sense right now, but it's just, this is Python. When I ran this, nothing happened immediately, right? And that's because there is no code outside of a function. So if you want your code to actually run, this is what you typically do. You say if underscore underscore name. So it's double underscore, okay? Called dunder, all right? Double under. Name equals double under main. Then I want to run main. So when you run a module, since, for example, I'm not running the turtle module, I just import these. But so you can, someone else, another module could import our rectangle, square, and polygon. And if it does, it will not run main. Okay. But what I want to have is if you do run this program, anytime you run a module, the name of the module is assigned the word main. Okay. So I'm going to do that, and it's going to, because of that, it will actually run my main. I could tell it other things. This is just tradition. That's why we named the method main. Excuse me, that's why I named the function main, because that's the name of the module that you run. It's given the name main module, because complex programs can have lots and lots of modules open and running at once. All right. I want to do a little bit more, though. I don't want to stop right now, so let's keep going. Let's close that off, and let's do a math module, because how can we talk about functions if we're not going to talk about math? All right, so let's save this as math functions. So let's define some functions. Maybe you have some in your algebra homework. So def f1, okay? I could call it just f, but I'll call it f1, and then I'll just call each one of my functions a different name. You're probably used to f and g or y, but we'll just stick with that. I'm going to say x. So this is a function just of x. I can have a function of x, y, z, all sorts of things. And I'm going to return 2 times x minus 5. So let's run it. So I've entered, that's how you enter a function. You know, we know in math class, I would enter it like this. I'd be like f of x equals 2x minus 5. Well, you can't put 2x. You have to put a times sign. And you can't say f of x gets the assignment operator. You have to define. Okay? All right, so we ran it. Let's try it. Let's try f of, what would f of 10 be? Well, it'd be 10 times 2 is 20 minus 5 is 15. Oops, F1. Yes, it's yelling at me. I got talking about F and I forgot. We call that F1. So you notice f of 1 returned 15. Pretty cool, right? We could even solve equations as well. But that gets a little dicey when you deal with decimals and things like that. But we could certainly give it a guess. I'll say guess equals negative 1,000. Let's say negative 10,000. All right, and I'm going to say while f1 of guess does not equal. Let's say we were solving it for equal to 15, because we already know the answer should be 10, right? Well, then I'm just going to increase my guess. All right, it stopped. So let's find out. And it tells me that the answer was 10. I could do that. I could even add it in the code to where it prints it out as soon as it's done. So yeah, we can do a lot of stuff with this. Let's take a look at some other things that we could do. Let's try, how about we make a count to function? Like maybe you're trying to teach your little brother or sister to count, right? Well, we can put a number there, and we've done this kind of thing a lot. We're just going to use a for I in range. So for I in range. Now, I don't want to start at 0. Let's start at 1. And I actually want to count to that number. Remember, the first tip, you only have to give it one number in range. If you give it just one number, it starts at 0. That's its default value. It goes up to, but does not include number, and it changes by 1. But we can change all three of those parameters. I'm going to put what it starts at to be a 1. I want it to go up to number plus 1 so that it actually reaches number, and I'll leave the default changing by 1. I can put it there, but you don't have to. It's optional. Okay, that looks good. Colon, and I'm just going to say print hi. So now I've got a method that I can call whenever I want to count. I want to count to 100. Thank you, Python, for counting to 100. Pretty cool, huh? I just want to scroll up and make sure it did start indeed at 1. It did. All right, super neato. Hey, who doesn't get tired of having to find slope of a bunch of lines in algebra class, right? Well, you know the slope formula, x1, y1, x2, y2. It's the slope between 2 points, right? Well, let's do that. The formula is y2 minus y1 divided by x2 minus x1. Now your Python has got, and you can save this in a module, you can import it later. You don't have to open it up every time. And we can just say get slope. Let's say 5 comma negative 3. That's my first point. And I'll tell you what, let's move the x over 4. And let's move the y up 12. So negative 3 plus 12 was that 9 again. Okay. 3.0. Boom. Okay, so that's pretty neat, right? One more that I can't help but do. You know how you get these equations when you're studying linear equations, and you have to find the zero, right, all the time, which is the x-intercept. So we call it get x-intercept or get zero. Well, how about this? You give me the m in y equals mx plus b form. You give me the m and the b, and I'll give you the zero, the x-intercept. So let's review our algebra. How do we do that? Well, we have y equals mx plus b, right? We got to solve for the x-intercept. So in the x-intercept, we have 0 for y. So when we subtract over the b, this will be a negative b equals mx. And then we'll divide both sides by m. So that's what I'm going to do. I'm going to return negative b divided by m. So now we have a way to get our x-intercepts. So I can say, or zeros. Let's say get 0. Let's see, if I graph y is equal to 2x minus 4, it should cross the x-axis at 2. So we'll do 2x minus 4. So that's my m and my b. All right. Well, I hope you enjoyed that, and hope you're starting to think right now of all the different things you can do in both Turtle and just in general with functions, because that's where it's at. Function-based programming is super cool. This was fun. I hope to do more stuff like this with you in the future. I can't wait for it. So until I see you again, take care.